Hey, welcome. So, have you ever found yourself just staring at a spreadsheet, one that's packed with numbers, and you're thinking, where do I even start? Well, if that's you, you're in exactly the right place. Today, we're going to tackle the most important first step in any kind of data analysis, figuring out what kind of data you're actually looking at. Because if you get this part wrong, trust me, your whole analysis could be totally off. So let's make sure we get it right from the get-go.
Okay, so take a look at this number, 167,402. By itself, what is it? It's kind of meaningless, right? It could be anything. A zip code, maybe, a product ID, a password. And this little puzzle, it gets right to the heart of our topic today. Without context, a number is just, well, it's just a number. The story it tells depends completely on what type of number it is.
And here we go. Here's the reveal. That exact same number, 167,402, can have two totally different identities. Over on the left, it's a part identification number. It's basically just a name, a label. You can't add it, you can't subtract it, it wouldn't make any sense. But on the right, it's an annual income. Now that is a quantity you can absolutely do math with, and that distinction right there is the foundation for everything else we're going to cover.
So that brings us to the first big fork in the road when we're talking about data. The difference between describing a quality and measuring a quantity. Nailing this down is the first big step to making sense of it all. This lays it out perfectly. On the one hand, you've got qualitative data. This is all about categories. Think about things like gender, hair color, or a direction like east. Now, sometimes we use numbers for these, like maybe 1 for male and 2 for female, but those numbers are just labels. You can't average them to get a meaningful result. Then, on the other hand, you have quantitative data, and this is numerical, stuff like salary or the price of something. And with these numbers, doing math like finding an average isn't just possible, it's actually really useful.
All right, let's do a quick pop quiz to see if this is making sense. Imagine a condo is up for sale. The asking price is $168,000. So, is that piece of information quantitative or is it qualitative? Just take a second to think about it.
It's quantitative, for sure. And here's the dead giveaway. You could take the prices of a bunch of condos, add them all up, and find a meaningful average price for the neighborhood. It's a measurement. It's a quantity.
Okay, how about this one from the very same condo listing? It says the unit has 2 bedrooms. So what about that piece of info? Is the number 2 here quantitative or qualitative?
Yep, still quantitative. Why? Because it's a count. You can have 1 bedroom, 2 bedrooms, 3, you can actually count them. And you could calculate the average number of bedrooms in a whole apartment building, and that number would tell you something really useful.
Okay, last one for this round. The condo faces east. What kind of data is that? Is east a quantity or is it a quality?
And that one is qualitative. East is a category. It's a label. You can't take east and west and find the average of them, right? It just doesn't work. This shows that core difference between a simple label and an actual measurement perfectly.
Awesome. So now that we've got our 2 main buckets, qualitative and quantitative, let's get a little more precise. Because even within those big categories, there are different levels of information. And to describe those levels, we use what are called the scales of measurement.
There are 4 of them, and they kind of build on each other, with each one giving us a little more information than the last. We're going to walk through them one by one. That's nominal, ordinal, interval, and finally, ratio.
So first up, we've got the nominal scale. The word nominal actually comes from the word for name. And that's exactly what this is, the most basic level where numbers are just used as labels. So if we say blue equals 1 and green equals 2, well, those numbers don't have any real mathematical value. We're just using them as shorthand to categorize things.
All right, moving up a level, we get to the ordinal scale. And just like it sounds, here, the order matters. The classic example is the rank of athletes in a race. You have first place, second place, third place. We know for sure that first is better than second, and second is better than third. There's a clear, meaningful ranking.
But, and this is so important for ordinal data, while we know the order, we have no idea what the difference is between those ranks. This quote nails it. The time gap between first and second place might be a tiny fraction of a second, but the gap between 10th and 11th place could be, several whole seconds. The spaces between the ranks aren't equal.
Next up, we've got the interval scale.
Now the gaps, or the intervals between the numbers, are equal and they're meaningful. The perfect example is temperature in Celsius or Fahrenheit. The difference between 10 and 20 degrees is the exact same as the difference between 20 and 30 degrees. But here's the catch. The 0 point is totally arbitrary. 0 degrees Celsius doesn't mean there's no heat. It's just the specific temperature where water freezes.
And that brings us to the top of the pyramid, the ratio scale. This has everything the interval scale has, but with one huge advantage: a true absolute zero. A zero that actually means nothing or none. Think about weight or income. 0 kilograms means no weight. $0 means no money. And because we have that true zero, we can now make meaningful ratios. We can say that 20 kilograms is truly, literally twice as heavy as 10 kilograms.
Okay, fantastic. We are almost there. We're going to zoom back in and focus just on that quantitative data, the numerical stuff, and make two last really important distinctions.
First, we have to distinguish between discrete and continuous variables. Discrete variables are things you can count in whole numbers, like the number of customers waiting in a line. You can have 0 people, 1 person, 2 people, but you can't have 1.5 people. Continuous variables, though, they can take on any value within a range. Think about the annual return on a stock. It could be 8% or 8.7% or even 8.765%. The number of possibilities is pretty much infinite.
So why does this even matter? Well, because we handle them differently, especially when we're trying to visualize them. We'd probably use a bar chart for discrete data, with little gaps between the bars. But for continuous data, we'd use a histogram, where the bars are all touching to show that the data can flow across a continuous range.
And our final distinction is all about time. Are we looking at a snapshot or are we watching a movie? Cross-sectional data is that snapshot. It's data for a bunch of different subjects, say a group of companies, all collected at one single point in time. Time series data, on the other hand, that's the movie. We're tracking one thing, like a stock market index, over a period of time to see how it changes.
So, wow, we've covered a lot of ground, from those two big buckets all the way down to these finer distinctions. But why do we need all these different labels? Well, it's because choosing the right tool for the job, the right statistical test, the right kind of chart, it all depends entirely on knowing what kind of data you have. This isn't just abstract theory. This is the absolute first, practical step every single analyst has to take.
Let's do a super quick recap of the whole framework. All data starts out as either qualitative or quantitative. From there, we figure out which of the 4 scales it's measured on: nominal, ordinal, interval, or ratio. If it's quantitative, we then ask, is it discrete or continuous? And finally, we think about how it was collected. Was it a cross-section or a time series? And that's it. That's the whole system.
So I'll leave you with this question to chew on. Just look at the world around you right now. The number of cars passing by your window, the temperature outside, the different colors of the buildings. What kind of data is that? And what scale is it measured on? Once you start seeing the world this way, you've already taken the first real step to thinking just like a data analyst. Thanks so much for tuning in.